Welcome, my name is Mathias Verraes. I'm a consultant. I have a consulting company called Aardling. We operate from Belgium, but we're quite international. We're still very small, but we help organizations with software design, architecture, domain modeling, as well as looking a bit outside, software strategy, socio-technical architecture, anything that sort of has an impact on the design and design quality. And I also organize Domain-Driven Design Europe, which is a conference in Amsterdam next month, well, obviously about domain-driven design. I'd like to talk a bit about design. There is a fallacy that seems to exist about how domain modeling works, about how software design works, right? There's this misconception that we can design software by sort of looking at all the concepts in the problem space, right, in the customer's domain or in the company's domain that we're working in, find all those relevant concepts, translate them into concepts in the code, and add some behaviors to it, and voila, we have a software system. And then you just sort of repeat that, and it's a very sort of incremental mindset of how design works, right? You keep adding something to it, and yet we end up with these, very incomprehensible systems that are hard to evolve and everything. And we even have a name for that thing. Maybe you've heard this, find the nouns. It's maybe not as popular now because object-oriented has been in decline a bit, I suppose. But it's how people, even if you haven't heard it, you might have done it, right? You just sort of look at all the names, all the nouns in that space, in that domain, in the specifications or whatever, translate them into objects or into schemas or entities or things in your design. And it's linear, right? There's this sort of path from A to B, understand the problem, apply design, implement, and done. I don't think it works that way. I think any attempt of trying to squeeze design in this sort of linear frameworks that people have, I think they're sort of missing the point of the very iterative nature of how sometimes it's engaging with the solution. It's trying to build solutions that gives you insight into how to better solve the problem, or what the problem even was to begin with, right? And I'm sure you've had an experience. It's just that we don't seem to capture that as an aspect of how we design software. If you've engaged with domain-driven design at all, or have heard about it, you might have heard this concept of ubiquitous language. Have you heard that, or is this entirely new? Okay, a few people. So, well, I think even there's a bit of confusion even in the DDD community of what that is and how it works. What it is, what it should be at least, the idea is that in a domain there's a domain language, right? There's the terminology that people use, and it's actually more than that, right? A language is more than just words. It's verbs, it's adjectives, it's how you construct sentences. It's what sort of things you would say and would not say in the language of that domain. It is how people express themselves in that domain, right? And in domain-driven design, we're saying we want to try to understand and capture that language. But it's not the same language. What we're doing in our design is not using those same language, or it shouldn't be, it can't be. Because that language is very much an organic language. Right? It's a natural language. It grows because people need to express something, and they either come up with words or they adapt words from some other thing. It's very messy. People will, have words that have multiple meanings, or multiple words that actually have the same meaning. They will have acronyms that everybody has forgotten what they mean. And it keeps evolving. It's a social language as well. It's always within a social group, people form their language to talk about what they're doing. Right? But that's not good enough for us as software designers. Right? And I use the term broadly, right? It's testers, analysts, anybody who has some kind of impact on the design. But when we're building software, we need to be more precise. Right? Software is very unforgiving. If you misspell something, it will refuse to compile, right? It's that strict about it. And so what we're doing in domain-driven design is making that process explicit. We're saying we need to look at that organic, messy, social language that people in that domain use, domain experts, customers, users, capture that and formalize it to some degree. Right? We need precise words. We need terms that have one meaning only, that are not ambiguous, that we can put in our code, that we have definitions for, that we can use correctly. So we formalize it. It's not formal. Well, it depends on your context. In some contexts, it's going to be very formal. In others, it's going to be quite informal. If you're maybe a young startup in a consumer space, you don't need a very rigorous language. If you are maybe an oil rig or something life critical, you need a very precise language. They will have RFCs for evolving the language even, right? And that precision helps us, right? We need that as designers to build software that actually works. Talking about oil rigs, my friend and mentor and co-author, Rebecca Wurzbrock, she was invited to help a software company. Well, it was a hardware and software company that built systems for oil rigs. It was basically sensors and telemetry, and so the hardware for that as well as the software to manage all of that. The way these drills work on oil rigs, I'm not an expert, but basically it causes a lot of friction, as you can imagine. So what they do is they add something called drilling mud, which is not really a mud, it's a fluid. It's a chemical substance that they make, put it in the hole to work as a lubricant. And it also works as a carrier. It will carry the debris and the rocks back up, right? So you can pull them out of the hole. And so they monitor that in real time for pressure and heat and I don't know what else. And then based on that, they will actually adjust the chemical composition of that drilling mud to adjust to fit to the friction they need, etc. And obviously, if that pressure gets too high, that's a really bad thing, right? And then an oil rig in the Gulf of Mexico exploded. 2010, you might remember. And so Rebecca was invited there actually to just sort of help them with software design and modeling and object-oriented and figuring out if they were doing things the right way, maybe some training. But of course that changed things. The whole team got sort of in a, oh wait, what happened, right? They're trying to figure out what happened. It wasn't one of their systems that was being used. And they didn't have any information back then about what had happened exactly. But it was like a warning sign, right? We need to do our job well or people die. So they started thinking, what could have happened, right? How could it have gotten wrong? It could have been, the software itself. It could have been a mechanical failure. It could have been, the chemical composition of the mud. Many possible reasons. Maybe something went wrong in, I don't know, the communication between the sensor and the computer system. All these kind of things could have happened. And they were trying to explore, like, how would we know? How would we know that we have the kind of problems in our software that cause these kind of issues? And so they started looking at it, right? When you're in doubt, when any, like a thing you're building for your client or anything you're working on, when you're in doubt, how it works, how that domain works, how it's supposed to work, start looking for examples, right? Start looking for scenarios. Ask questions about, what happens, and then what happens after that, and then how do you get there, or what happens in this situation. So you can sort of poke at it, because usually people will tell you in a very generic sense, like this is the purpose, or this is what it's supposed to do, or even worse, they will tell you you need to add a button there and a table there, and they don't tell you really how it works. So you need to dig for that. You need to get to those domain experts, ask them these questions. And so they're doing that, and they're asking, they're looking at the software itself, they're looking at the logs, and as they're asking for these scenarios, what happens? What happens when there's an incident? What if the friction gets too high, or the pressure gets too high? So, and what if it's a catastrophic condition? Right? So they tell them, okay, the alarms go off, and then we start fixing the problem. Right? And then as they ask more questions, right, what happens to the alarms? They learn that if it's a simple problem, right, they just fix the problem, turn off the alarm, and it's done. And then the logs of the software system reflect that the alarm has been turned off and that the incident is over. However, if it's a much larger incident, after a few minutes, they still turn off the alarms because it's a noisy environment, alarms and everything, you want to focus on solving the problems, you turn it off and you keep working. But in the logs, it still says, after 5 minutes, the incident was over. You could think of that as just a bug, right? Oh, it's a bug in the code, or it's a little problem. We can patch it, and we're good again. But that's a missed opportunity, in my opinion. There's a flaw in the model of how, not just the system itself, right, but how we think about how the system works, right? The system itself has actually the wrong perception of what's happening, right? It thinks that the problem is over because the alarm was shut down. That's not what happened. So the system is wrong in a sense, right? There's a fact in reality, the incident is longer, but our interpretation in the system is different from that. So you need to use that, right? There's an opportunity there to help that shape your understanding of that system. Right? There's something missing. There's a concept missing in here. And that's why it's called design and reality, because we tend to think that our job is capturing these concepts from reality and turning them into software. You probably haven't ever had that thought specifically in your head, but that's often how we reason about it. Whereas here there seems to be a concept missing that doesn't exist in that domain, that doesn't exist on the oil rigs, that the oil rig engineers don't talk about. They don't have it in their domain language. It's also never going to show up in the specifications. So there's something missing in between. Like the assumption was that there's a direct connection between the error condition happening or the sensors detecting something and the alarm going off. That's like a straight line. Right? Where it turns out there's something in between. So again, when you're dealing with these sort of weird situations where, sure. No, that's the slide. I'm sorry to disappoint you. I just have some notes here. Now I lost my thread, so I'll check my notes. So this kind of thing, right? When there's something where people are not really sure how it's supposed to work, you can think of that as your model of the system. You can think of that in the same way that we think about scientific models, right? In science, what is a model? It's a good enough understanding that allows us to make predictions about natural phenomena. Right? I don't understand quantum mechanics, but I understand Newtonian gravity enough that I can predict that if I push that glass of water, it will fall down. So my model is good enough for my situation. In software, this is actually in a way the same thing. Right? Is my model, my understanding of how the system works and how the domain works, good enough that I can make predictions? Right? So they start looking for the places where they cannot make these predictions, actively looking for it. What happens, that was one of the examples, what happens if you have two separate sensors that each detect a separate condition? Should the alarm, you can't raise the alarm twice at the same time, right? There's only one alarm. You can raise the alarm, and then when somebody turns it off, raise it again for the second error condition. But what would happen? Yeah, somebody would turn it off, it would turn on again. Oh, that button didn't work. Push it again and be done. And the logs show, minuscule situation that was solved in a second. Yeah. So what happens, right? And so they start understanding that this intermediate concept is important, this alert condition. They start naming it, right? Now it has a name. Now it's a thing, right? They start, they weren't like changing the software right away. You don't do that in Oryx, but they started sort of doing some little proof of concept. What if alert condition is an intermediate concept? Something that you can think of it as an object in the code. It was probably a bigger model than just an object, but it's now explicit, right? It used to be something that didn't even have a name. Right? Of course, alert condition is not, a made-up word or anything. It exists in the English language, but it didn't exist in the language that people were using to talk about their work as Ulrich engineers. And their job is not to be a language designer or anything, right? That's on our end. So, and then now when you see this, right? So I hope you can imagine. So you have now the sensors that detect something, reach some threshold, and it triggers not the alarm, but it triggers an alert condition, which is now on, right? And that alert condition can now trigger the alarm itself. But because we have this intermediate concept, first of all, the log problem, we can solve it now, right? Because we can now track in the logs when the alert condition was turned off, separate from when the alarm was turned off, right? So we get that separation. And now we have this explicit concept that we can start using and building a richer model around, right? We have a deeper model. But it didn't come from reality, right? It wasn't written in a specific, nobody told them, hey, when you design this system, make an intermediate alert condition that will manage, the connection between the actual thing being measured and the alarms going off, right? It is an act of creation, right? It may sound like very often with these kind of things, maybe now this is very obvious to you, I hope. This model now, it used to have two elements, now there's this third element in the middle. Once you see it, it's hard to unsee. That's often a property of these sort of models that emerge. And then people say, oh, why didn't you do that right away? Well, because we couldn't see it yet. Nobody had seen it. Then people will even tell you, oh, I always thought about it like that. I just didn't have a name for it. Well, sure, but that had no use to us, right? Oh, you thought about it, great, right? And maybe, like, how do you even find something like that, right? So find examples, go through scenarios, like keep pushing at the model. Here in this case, actually, maybe it reminds you of, that's not how they came up with it. But in retrospect, you can sort of try to understand what principle or what heuristic is behind that. Maybe here, what did they actually do? In terms of software, I'm not sure you're going to guess. I'll just tell you. So what they did is they decoupled presentation from logic, right? You know that, right? You know that in software design. That's a good thing, right? So the model that dealt with the alert condition and then the alarm is really just a user interface, if you think about it. They decoupled it. So that's not how they came up with it, but having these heuristics can help you push at different design, right? Maybe your concepts from the UI are too coupled in your design in the backend or in the domain model. So yeah, it didn't come from nothing, right? It came almost from nothing. It didn't exist anywhere in the space. And now that we have it, maybe first in the software or in the models, but now it becomes a thing, right? We're actually pushing language back to that domain. The Ulrich engineers start to also think about that, right? Now they have a concept for it. So I know it's called domain-driven design, but sometimes your design actually drives your domain again, right? Your solutions that you come up with teach you something about the domain that you're solving or the problem that you're solving, which is a very, usually those models of how to do design don't include that idea, though. We reframe the problem, right? We put a different light on what the problem is. The problem is not sounding alarms when something is measured. The problem is managing alert conditions and notifying people about it, right? It's a whole different framing. Is this a better model now that we have alert condition in the middle? Right? We need to ask that question. Maybe this sounds nice, we had a good idea, but it doesn't actually work, or it's just over-design, or it's noise in our system. But in this case, I would say it is, right? Because we can have much more, we have more precise measurements and logs, right? That's problem number one that is solved by this. But now you can start to extend that model. You can make it a lot more richer and deeper. For example, we can start qualifying alert conditions, right? This is a critical or high or low alert condition. That in turn could solve the problem with the simultaneous alarms, right? It could say, well, if you have a highly critical thing happening and a low incident happening, you raise the alarm for this one. Or if this one, it's a problem, but you have 2 days to solve it, and it's a problem. If you don't solve it, you blow up. you can start modeling that in the software and coming up with rules about how that works. So that's a powerful thing. We can even start doing things like evolving the alert condition over time. So maybe something happens. It's a highly critical thing. We start doing some fixes, and then we lower the condition from highly critical to medium critical. It's not finished yet, but we lower the status. Right? So what we're basically doing here, what I'm trying to show here is by testing your new model against sort of all these, like what sort of things could we do with it? I'm not saying we're going to build all of that, right? Maybe we don't need it, but you're testing your model against sort of all kind of things that you can imagine having. People will tell you, oh no, that's an edge case, don't waste time on it. I'm not saying we build it, that will be costly. If we build for an edge case that never happens, then that's costly. But we're just testing our model. We're trying to sort of poke at it, probe it, see if it holds up. Again, throwing scenarios at it, right? What would happen if, in this scenario, with our new model, would it be able to deal with that? Right? We don't build all of those edge cases, but we use them to push for. And people will still say, right? Why do all this work if we're never going to build that anyway? But it deepens our understanding. We might find these sort of better models through it. Right? That's the idea, right? Pushing awkward scenarios. It's so powerful. Yeah, but what if this and this and we don't actually know. That's an interesting question. Now you're onto something, right? And so what you notice is that that's the beauty as well. Or a sign that your model is better is that this concept gets adopted by the people in the domain, by the oil rig engineers. Now they start talking about alert conditions and not about alarms. Alarms are just the noise that an alert condition makes to warn you. So through design, we are creating these new realities. Right? We underestimate this. We are sort of too linear in our thinking from problem space to solution space is a straight line. But we're like gods, right? As programmers, we can create new worlds, and we end up with things that, like in this model, right? This new model with alert condition, it's more useful than the previous model. It's not more accurate, right? Because alert condition didn't exist. It's not more realistic, right? It's not a thing in the domain that existed there. It's not more precise or anything. It's not more correct, because all models are wrong anyway, but it's more useful for our situation, right? We make that design work for us. That's very powerful. It's a domain model still, but it's not just a model of the domain. It's also a model that gives us new options, new flexibility, new freedom. And the solution of introducing that concept clarified the problem for us, right? So this linear view where you first understand the problem and then solve it, well, if you're like a genius designer, you will come up with the best possible solution. For the rest of us, we need to iterate over that. Not just increment, not just add stuff on top. You wouldn't have found it that way, but you need to sort of rethink what you're doing and reconsider, given what we know now, is this still the right way to do this? Right? Are we missing something? Is something awkward? Are we jumping through hoops to achieve something in this domain? Is it making sense? Excellent. So I have another example. It's a bit more involved, but I think it will make sense. Years ago, I was consulting for a startup that was doing payouts for claims on content. So if you were the copyright owner of certain copyrighted content, you can make money off that because it's being used, like music being played on the radio or whatever. And you can make money. You can make money off that. You can make claims that that song is yours. It was played there. You get paid. And the startup was they were still very young, and they were actually I was invited for more technical consulting. They were doing event sourcing, which was pretty new at the time. And I was invited to help them with that and architecture and sort of figuring some things out. And of course, as a domain-driven design guy, I can't resist, right? I need to understand the domain as well. I want to like see how it works and not just offer a technical solution for a problem I don't understand. So I start, having them explain what they do, and we start drawing on the whiteboard, and we do event storming, which is like visualizing the business processes that were happening. And I noticed that we couldn't get the business people to be involved in that. Right? They weren't really interested. They were always talking. The engineers were always talking about data matching, and so were the business people. But for them, it was sort of data matching, that thing you do, right? They were domain experts, right? They were domain experts in the field of copyrights and all of that, copyright laws and copyright management and I don't know what else. But they weren't experts in this system that they were trying to build. The point of the whole app was, of course, to automate this process as much as possible, right? And to make it smart and reduce the amount of manual work that had to happen with these things. So the way it worked, they would pull data from many different sources, which could be like existing databases from publishers of that content. It could be databases from third-party vendors where you pay for access to that data. But there would also be more, well, think of it as wiki style, like public databases where people could, where anybody could edit things. They would also get claims from individual owners or from smaller publishing companies that didn't really have like, any kind of advanced system. Some of it would be, just spreadsheets. You can imagine how this works, right? Or even Word files, right? So they have a data problem, right? They have all this data that they need to, or data quality problem that they need to get into a good shape to start using it. And then, so it's a lot of, filtering and cleaning up and, doing this sort of operation. And then they would try to match these claims. So what that meant was they were trying to assure that a claim was correct by comparing it between different sources. That was the data matching, right? So they would look at this claim here is coming in from this source. There's a claim coming in from this other source that gives us a higher probability that this claim is in fact, if it's the same claim by the same person for the same content, that's a higher chance that it's actually correct. Because there is an opportunity for fraud, right? You could claim ownership of a work that you didn't own through these channels and try to get paid for it. And even that, right? It's not that everybody was trying to fraud them, but you just needed to be sure, right? Because you're paying out this money, if you pay it out to the wrong person, you have a problem. Right? And that was the whole business idea anyway, right? That they would make this much smoother and easier. And I don't recall, but they had like probably marketing that said, leave the worries to us or something like that. Always, or get paid faster. That would probably be a better line. So it was a very technical thing, right? That's how the engineers thought about it. It's a very technical thing. It's data and matching and a whole bunch of nested if statements all over the place. And still I was pushing like, let's model this. Let's try to visualize this. Because there were a few engineers that sort of really understood it well, but they couldn't explain it very well. It was clear that they understood, and they had built it, but they couldn't explain it very well. So it became this sort of thing where most of the newer engineers wouldn't really touch it that much, or they would need to touch it a bit, and then they would sort of try to, add something somewhere in that nested, if statement thing, where you're always like trying to reverse engineer what's happening before you can even make a change. So we start modeling it, and we start having these conversations. And what happened was I started paying attention to that language, right? They're talking about these claims. They're talking about validating these claims. They're talking about some sources where they had more trust in that source. Like if you pay if you pay a license fee for some data, you expect it to be better than if you grab something public from some wiki kind of thing. So you have more trust for it. And gradually I started sort of this paying attention to this language, right? The subtleties in this language. They were talking about sources and data matching and all these sort of very technical terms, but they were talking about trust. So So at some point, I just sort of randomly said, what if trust is a thing here, right? What if this is an explicit concept? Tell me a bit more about that. How do you gain that trust? Oh, if we have a source and then we get multiple confirmations for multiple things, that multiple claims, and we get other claims that confirm that over time, multiple times, we should actually be able to assign more trust or allocate more trust to that source. Right? So okay, let's. Where is trust in the code? Can we put that in there? All right. So what we did now, just as sort of a quick experiment with some tests at first, trust is an object now. It's an object called trust. Again, it didn't come from, it existed in the conversations, right? But it didn't exist anywhere else as a thing. It was just sort of a feeling, right? We turned it into an object, and we started thinking, okay, and looking at the existing code, right? How does it work? Well, it's adding up numbers to validate these claims. Well, let's put these numbers in that trust object. So now we were actually quantifying trust. This source, this claim, this owner, this copyright owner, we trust them this much or this much. Right? Just a very simple object, a value object. It's just a number wrapped in a class, basically. But we started seeing that this is a pattern, right? That at different places, this number that didn't have a name was always trust that we were updating. So, and we start talking to the domain experts, and oh yeah, that's what you're doing. That's trust. They started grasping or holding on to this concept and bringing it in the conversation, and they were starting to get more interested in joining us because now they had a concept they could talk about. And we started thinking, yeah, but what happens if we trust this source a little bit? Let's say we trust it with a value of 1, and then this other source we trust it with a value of 5, and they make a claim and they corroborate the claim. So we can now increase the trust in that claim, but also increase the trust in that source. In that source. So coming from domain experts, we started seeing this as an arithmetic of trust. Right? So now we had for some reason, right? We had a scale from -5 to 5. 5 being, of course, we fully trust claims coming from this source, or we fully trust this owner, or we fully trust the claim itself. And then the business started sort of mapping out how they wanted trust to be updated based on some other claim confirming it. Right? So it wasn't arithmetic, it was rules about, because if you had a trust of 1 and somebody else gave you, confirmed it with who had a trust of 5, it wouldn't be 6, it would increase a little bit depending on the situation. So we started thinking of trust as a process, as an evolution, and then having the mathematics, the arithmetics that decided the rules on how to change that trust, and then formalizing that in the code. Right? So now we had basically our simple value object now had actual behavior attached to it, the logic that would calculate trust. And all these places, we started looking into refactoring that. All these places where this unnamed value was calculated, we started moving that logic into that trust object. So now all these places could start sharing a single object, a single concept that represented the concept itself along with the calculations and behaviors on top of it. Making sense? It's very powerful, right? Now we have something we can sort of point at and start doing things. And again, is this a good model? It turned out to be a very good model, simply because of all the things we could start doing that we had never really, or that they had never really been able to do properly. For example, they started understanding how, stuff that was sort of nested in if statements with the if, literally naming hard coding the source. If the source is this source ID, then we automatically assign more trust to it or something. That was hard coded in there. Whereas now they could start thinking about it, okay, so basically we have different strategies for updating trust depending on the source and depending on other things like the different markets they were in. In one country, maybe they would do it differently than in another country. I don't know if you can sort of see where this is going, but trust went from a value object now to something bigger even. It became, they started having different implementations of trust. Right? it became somewhat like a strategy pattern, right? It's polymorphic. So we have, let's say, the trust interface, and then we have implementations that could work differently depending on their inner logic. And then for every source or every market or every whatever, you could use a different trust. And then, well, the next step is dependency inversion or injection, right? Instead of fetching the ID and the rules about it and applying the rules about it, you just get injected the trust strategy object for that situation, and you can just use it without understanding how it works. So that all that nested if stuff with the configuration and the options and the hardcoded stuff, it just sort of collapsed into these nice strategy objects. Right? Is that making sense? It's maybe a bit abstract to see it without code, but then we'd have to spend all night. Also, I'm not allowed to show it anyway. But it's very powerful, right? What we did here, and that might not be so obvious, but trust, in this case, is a metaphor. Right? It's not actual trust. Actual trust, that is, a feeling. You trust somebody, or you don't trust them anymore, or you're sort of losing trust maybe in them. That's not what we're doing here. Here it's numbers, right? It's still data matching and data comparison. It's a metaphor for real trust. Computer systems don't trust computer systems. They don't have feelings, right? It doesn't exist there. It's a way that we explain through metaphor what the system is doing by comparing it to a human thing that we do understand. Even if I wouldn't even be able to define trust, maybe, but we're using metaphor to explain how it works. This is not, go ahead.
But when you redefine trust from having if statements to having a calculation like that, how do you manage to keep the same results for backwards compatibility with how the world worked before you introduced these new calculations?
Well, they were a fast-moving startup, right? They were not trying to have backwards compatibility. They were trying to invent how they were actually going to do this business. They didn't have to care much about backwards compatibility. That said, they were still trying to find, basically refactor that code, find stuff like here. Okay, here's a bit of code that deals with, this publisher, for example. Let's pull that out, put that in a place specifically named after that publisher, for example. So it could be a foobar publisher trust strategy, and it was not just one trust interface anymore. By the end, it was different kind of concepts. But they were trying to keep the existing code, but just move it to a place where they can give it a name instead of just being sort of code and numbers being calculated. So the goal was not to be fully backwards compatible, but to have more control over how the whole thing worked. Right? So I do think that probably it was somewhat close, as they kept evolving the system, that they wouldn't randomly have completely different results. There's people also looking at these numbers, right? If suddenly, you have to actually make the payment. If at that moment you see that, this party used to get, a few €100 a month, and now suddenly we need to pay them $1 million, something is off, right? But I'm not aware that anything like that happened, anything that critical. So maybe the numbers might have been slightly different. But the idea was that it would be, in any case, more accurate now, because we understand what it's doing. We can predict what it's doing. So there might have been unpredictable things happening, because if you have enough nested if statements, you cannot understand it anymore. But if you have clear separate objects, and okay, now we're only using this object, we're sort of scoping all these things, right? So they get more control over it. They get more, like these objects, right? You could start not just injecting them, but you could configure them. We could say, for example, this whole set of publishers, they all fit the same pattern. It's just that the percentages are different or something. I'm making up stuff, right? But now you can configure this object and say, okay, the X style publisher, and for publisher foo, we configure it with 10%. And now we take that object, inject it somewhere else, and that thing now uses that object without having to understand how it works. But you gain control over the whole thing. Right? It becomes obvious where something is supposed to happen, where you're supposed to change it. This is in general a feature of, I'd say, mature quality software design. At a certain point, you get over time, right? If you keep sort of doing these kind of improvements and finding the right concepts and naming them and making it, encapsulating them, over time you get to a point where, well, first of all, the flexibility of the system is going to be in the places where you need it, assuming you don't over-design. But whenever you encounter something like that, oh, we have actually 3 kinds of publishers, right? You make an abstraction that allows you to have different types of publishers. And now the 4th time you have a new type of publisher, it becomes very easy. You just add another publisher of that same type, right? So mature software design has this quality where everything you're trying to achieve, every new requirement, every change, maybe the laws change or whatever, it doesn't provide that feature yet, but it becomes obvious where to put it. You can either add something of the same type, remove something, configure something differently, change the order of steps in a process, and it all becomes like Lego blocks. You get a higher level of abstraction where you can, instead of playing with raw code, you're playing with domain-level concepts. Trust, publisher, and it starts working. Rules, the business rules about how you do stuff, you bring them into first class as well, right? You start naming the business rule. That's what we're doing here with these strategy objects, right? We're saying instead of business rule or business logic, it's if statements hidden inside the code, we're saying now it's an object with a name that we can pass around, that we can have polymorphism for, Liskov substitution, right? These kind of things that are very focused on a single goal. And so your software design becomes a lot more malleable, right? Because you're at a higher level of abstraction. And yeah, the point I was making about metaphor, I'm not sure if that's very obvious, but well, anything in our life, in our language, almost anything is metaphor. If you read George Lakoff, Metaphors We Live By, my career is going up, a career ladder. Up means better, right? We don't even think about it, but all the metaphors are consistent. My career goes up, my salary went up, my life satisfaction went up. It's a ladder, it's a pyramid, it's always better is up, or up is better, and down is worse. I'm feeling down, right? Worse. I could probably come up with more examples, but there's sort of a consistency in the metaphor where up is better, down is worse. You won't really find the opposite. And then it even depends on cultures. In some Eastern languages, centered is better, outwards is worse. Right? So, well, I'm not going to explain the whole book, but metaphor in this sense is, trust in this sense is a metaphor, right? It's not actual feelings between machines. It's our sort of metaphor that we put on it to understand it. And that's very powerful. If you, like in XP, in domain-driven design, they talk about system metaphor, this idea of can we explain that system through another metaphor that helps us understand it. And in this case, it didn't just help us, it involved the business people who suddenly had a sense that they knew what their system was doing and could control it and have discussions about it. Any questions? Sorry.
You were talking about having these models and then iterating on them and then affecting the problem space and then changing your model again, but then you added new scenarios. And are you all in those spaces?
Sorry.
I was just wondering if you're
Just a second, because I can't really hear you. It was a great talk, apparently. Go ahead.
No, I was wondering when you were talking about going back and then remodeling and then going through these iterations and creating these scenarios where you keep asking, you're not in code yet, right?
I'm not in?
You're not coding yet, right? You're still
What we might be doing is like code probes. We're maybe writing some tests so we see how it would work. Maybe write some simple implementation. but not start doing actual database schemas, don't start doing UIs, just some, and get a feel for what it would feel like to work with code that was working that way. That's sort of the idea.
I was just wondering because as you add more and more scenarios, when you then change the model, I was wondering how do you regression test the previous scenarios under the new model that you're now working on?
How do we, everything is trying to drown you out. So how do we test? Regression testing, yes.
Scenarios that worked on the previous model, then you change the model.
Yeah.
And to work with the new scenario.
Yeah.
It also probably affects previous scenarios or not in this case? I don't know.
Yeah. So well, maybe the broad question is how do you get stable tests for changing models, right? Which of course is not always going to work. But what I like to do is think about it in terms of abstraction level. Right? If I'm writing a test, I always want to be at a single abstraction level. So an extreme example, if I write a test that calls, that goes to my website, pushes a button, and then asserts a value in the database, I'm at two entirely different abstraction levels, user interface and database. It doesn't make sense, right? Nobody looks at the system that way. I try to write tests about observable behavior at one level. Right? And then you can do this at different levels. Right? I might have a low-level test that tests, if the database integration works. I might have a higher-level one that tests at the level of my model. Right? I try to have fast unit tests that don't call the database, that have no side effects, where basically the beef of my testing is about the domain model. I want to be most sure about that. And then, of course, assuming that your domain model is nicely decoupled, which it wasn't in the trust example, but over time we got there. But this, think of this domain model as a standalone code, just plain old objects that don't do anything else, no framework. You can easily write a lot of tests at that level. And then you can go one level up, which is sort of how is the rest of your application supposed to interact with that model? So like high-level domain services, right, where you can just send a command to something and get a response back. And then a level up could be at HTTP level, right? I send an HTTP request and I validate the response that I get, stuff like that. And then maybe at user interface level. So, and now if you're going to change low-level model, your high-level APIs are not going to change. So you have tests that still give you some, confidence in the whole thing, even if inside you're changing things. And you're writing new unit tests for the things that you change, get rid of the ones that you don't need anymore, but the higher level integration is still tested. Does that make sense?
Yeah, I think so.
All right. We have a few more minutes if there's any other questions.
Going back to your example with the oil rig, couldn't you argue that it was that designing a software system or thinking about the software system really helped them doing business analysis? That the concept of condition they should have already known because they are involved in a domain where lives are at stake. If I think about the military, from Hollywood movie, the DEFCON level. So it's not an unknown concept in other
Sure.
things. So
Yeah. Well, I maybe should have added some context. I massively simplified the real thing. It probably wasn't like that. Also, I wasn't there. You're saying they should have discovered this earlier, right? That's cover your ass, right? Somebody else should have solved this problem earlier, but they didn't. It wasn't there, right? And you're right that if they had maybe research existing literature that they would have found stuff. But you can also not research everything. You cannot, at some point you need to actually build something or you get stuck in analysis paralysis. And, you've worked on systems that weren't perfectly designed and that probably should have been different at any kind of level. So also this was all problems that hadn't happened, right? They looked at this other company's thing that had failed, the Gulf of Mexico thing, but that was not their software and their systems. They haven't had any accidents. So it's not that, there's no evidence that it's unsafe. Of course, that's not proof that it's safe, but so I'm sure the system was, actually as a whole working pretty well. Also, it's massively simplified, right? Because they don't just have an alarm going off telling them that something is wrong. They have monitors and they have dashboards and all kinds of things, and they're actually there on the ground. They're on the oil rig on the sea, but it's much more involved than this sort of very simplified explanation that I'm giving. So since then I'm not aware that any have exploded. So it's probably not that bad. But you're right? There could have been, if it's life critical, you want to do this kind of work up front a lot more than if you're doing like a startup in a consumer space, right? Where you want to start, where you have to start proving your market before the money runs out, right? Good design or not. And that's maybe as a closing thought, right? What is good design? There's people like in DevOps, there's this mindset that, you need to be able to deploy every second. And no, you need to be able to deploy at the speed of the problem, of the business, of the thing you're doing, which is, maybe every second at Facebook, which is maybe, a few months at an oil rig. I've consulted for a drug pump fluid a company that made the software for drug pumps for hospitals, for patients, like chemotherapy and stuff like that. They don't want to deploy every second. And the same with design, right? What is good design? If you're a startup and you have an 18-month window to prove your market, or the money runs dry, then good design is whatever gets you to that next investment, right? If it's life critical stuff, good design is whatever helps you make a safer system. If it's money payouts, good design is whatever gives me confidence that we're paying the right money to the right people and not like losing money left and right. Right? You need to make the design work for you. You need to organize it in a way that it solves your problem. Dry or single responsibility, or we tend to throw these principles at things as if they're universal, but they are also contextual, right? Don't repeat yourself is a design principle that exists because if you duplicate things, you have higher maintenance costs. But if the maintenance cost is actually low, then maybe that duplication is cheaper than having to unify all these systems and trying to coordinate all these people to make sure that we never have the same thing or information twice. Right? So you need to make the design work for you. If that means coming up with concepts that didn't exist, you can do that. Of course, you need to do that with the domain experts, with the people on the ground, with the users, so you know that it's valid, that it's not just fiction in you and your team's head that looks nice on paper, that you can have nice diagrams, but that doesn't actually solve their problem. All right, thank you very much. Thanks for joining. I have some resources. Thank you.